For Germany during the later years of World War II, ordinary weapons were no longer enough. The Allies had gained momentum. Armies were stretched thin, and entire fronts seemed to crumble under pressure. In this climate of desperation, German scientists, engineers, and military planners began pouring their energy into what they called Wunderwaffen, miracle weapons designed not just to fight battles, but to reshape the very rules of warfare. These were not incremental improvements on existing tools. They were leaps into a future that most nations couldn't even imagine. The idea was simple. If conventional methods were failing, then extraordinary technology could achieve what sheer force could no longer deliver. The ambition behind these weapons was staggering. It wasn't enough for them to be powerful. They had to be game-changing. Rocketry, jet aircraft, guided missiles, super heavy tanks, and even early experiments in stealth and long-range artillery all emerged from this mindset. Each project was an attempt to take the impossible and make it real. To seize control of the battlefield in ways that conventional military doctrine had never accounted for. In theory, a single breakthrough could reverse the course of the war, or at least prolong Germany's survival long enough to negotiate more favorable terms. In practice, these weapons became symbols of both human ingenuity and the hubris of a regime racing against time. At the heart of the Wunderwaffen program was a philosophy of innovation driven by necessity. Engineers were encouraged to think beyond the traditional limits of warfare, to question what was achievable. Some of the concepts were frighteningly advanced. Rocket programs, for example, were no longer just about artillery shells or bombs. They were about sending payloads across long distances with precision. Jet technology was not just faster aircraft. It represented a complete revolution in air combat, promising speed and maneuverability that could outmatch any existing Allied fighter. And then there were projects that bordered on science fiction. Submarines capable of operating without surfacing, tanks designed to crush fortifications with unmatched armor, and even preliminary work on nuclear weapons. All of this existed simultaneously, sometimes in parallel, sometimes competing for the same limited resources. What's remarkable about these weapons is how they reflected a mindset that was part technological genius, part sheer desperation. Germany knew it was losing on conventional fronts. Its armies were stretched from the Atlantic to the Eastern Front. Resources were dwindling, and industrial output could no longer match Allied production. In this context, the Wunderwaffen were both a psychological weapon and a real one. They served as propaganda to boost morale at home, promising that victory was still possible if only these marvels could be deployed in time. But they were also tangible attempts to force a shift in the war, to create tactical and strategic advantages that conventional forces could no longer deliver. Despite their potential, there was a fundamental tension in the program. The same creativity that produced groundbreaking designs also collided with the harsh realities of war. Manufacturing these weapons required precision, materials, and time, all of which were in increasingly short supply. Allied bombing raids disrupted factories and supply lines, making the deployment of these advanced systems slower and more unpredictable than intended. Engineers often worked in secrecy, under immense pressure, with constant interference from military leaders demanding immediate results. Even the most brilliant designs were vulnerable to logistical failure or the simple fact that the war had already moved beyond Germany's control. Yet the ambition of the Wunderwaffen program cannot be understated. Each weapon, whether it ultimately succeeded or failed, pushed the boundaries of what was considered possible in warfare. The vision behind them transformed conventional thinking, inspiring generations of scientists, engineers, and military strategists long after the war ended. They demonstrated that innovation under pressure could achieve extraordinary leaps, even when the circumstances were dire. And while none of these miracle weapons changed the outcome of World War II, they remain a testament to human ingenuity at the intersection of desperation and invention. This was a world in which imagination became a tool of survival, where engineers and scientists became soldiers in a technological arms race, and where the line between science fiction and reality blurred on the factory floors and secret laboratories of Nazi Germany. These weapons were not just instruments of war. They were a statement, a gamble that human creativity could bend history itself. In examining these developments, we see a Germany striving to rewrite the rules of conflict, desperately reaching for a future that, in the end, would remain just out of grasp. Germany's rocket programs during World War II were unlike anything the world had ever seen. While traditional artillery and bombs had long defined the battlefield, the vengeance weapons, V-1 flying bombs and V-2 rockets, represented a leap into a completely new dimension of warfare. They were not just tools of destruction. They were statements of intent. A demonstration that Germany's engineers could bend physics and mechanics to deliver devastation across vast distances. The idea was simple yet terrifying. Strike the enemy where they felt safe. Deliver terror without the need for a conventional battlefield. And create the illusion of an unstoppable technological force. The V-1 was the first to enter practical use. Often called the buzz bomb because of the distinctive noise its pulse jet engine produced. It was rudimentary by modern standards but revolutionary at the time. Launched from fixed sites in occupied Europe, it could travel dozens of miles before striking its target. It was crude in guidance, flying along preset gyroscopes and engines. Yet even this level of automation was astonishing in 1944. Civilians and military personnel alike experienced the psychological terror it produced. There was no warning, no traditional battle to fight back against. The V-1 turned everyday cities into potential targets and forced governments to devote massive resources to air defense. The V-2 rocket took this innovation to an entirely new level. Unlike the V-1, it traveled faster than sound, making it impossible to intercept with the technology of the time. It was the first human-made object capable of reaching the edge of space before descending onto its target. While the V-1 could be shot down or deflected, the V-2 arrived silently and explosively, leaving devastation in its wake before anyone could react. The engineering behind it was astounding. Liquid-fueled engines, precise guidance mechanisms, and a level of coordination in design and production that few countries could match. It was a weapon that blurred the line between science and warfare, showing that technological ambition could create terrifying new possibilities. But the rockets were never purely about physical destruction. They were as much psychological weapons as they were military ones. Each launch broadcast Germany's message that they had the capability to strike without warning, that the war was not yet decided, and that the front lines were not the only place fighting occurred. For civilians in London, Antwerp, and other targeted cities, it was the feeling of vulnerability that left a lasting impression. For the Allies, it was the proof that German technology had leapt years ahead in certain areas, creating pressure to respond with both countermeasures and accelerated innovation. Yet despite the sophistication, these programs faced severe limitations. Production was slow and resource-intensive. Factories and launch sites were vulnerable to Allied bombing campaigns, and transporting the materials required secrecy and security that were increasingly difficult to maintain as the Allies advanced. The rockets, impressive as they were, often arrived too late to alter strategic outcomes. Their impact on morale and terror was real, but they could not replace the conventional military strength Germany was losing on multiple fronts. In essence, the V-1 and V-2 were a glimpse of the future of warfare, but their promise came too late and under circumstances too dire to change the course of the conflict. The program's legacy, however, extends far beyond World War II. The engineers who worked on these rockets carried their knowledge into post-war rocketry programs across the globe. Wernher von Braun and his colleagues would later be central to the U.S. space program, proving that the technical breakthroughs of war had peacetime and exploration applications. These weapons were simultaneously a technological triumph and a moral ambiguity. Tools of terror born from desperation, yet also stepping stones to human advancement. The vengeance programs highlight the unique intersection of ingenuity and necessity in wartime Germany. They demonstrate how innovation can emerge even in the most extreme circumstances, but also how brilliance can be constrained by logistical reality and timing. For Germany, these rockets were the embodiment of hope. A hope that technology alone could turn the tide of a war it was rapidly losing. For history, they remain a powerful reminder of how rapidly science can evolve under pressure, how the line between progress and destruction can blur, and how the most advanced weapons in the world cannot compensate for strategic collapse. In examining the V-1 and V-2 rockets, we see not only the genius of German engineers but also the limitations of technological ambition. In a losing war, they were weapons ahead of their time, terrifying and effective in some ways, but ultimately unable to overcome the broader realities of World War II. And yet, their story resonates, showing us how innovation, when driven by necessity and fear, can reach heights that are as impressive as they are dangerous. Germany's jet aircraft program during World War II represented a leap that left the rest of the world scrambling to catch up. While most nations were still perfecting propeller-driven fighters, German engineers had taken the bold step of developing aircraft powered by jet engines, introducing unprecedented speed and maneuverability to aerial combat. The Messerschmitt Me 262, perhaps the most famous of these jets, was not simply an incremental improvement on existing fighters. It was a vision of the future, a glimpse of what air warfare would become decades later. Pilots who flew the Me 262 described a sensation unlike anything they had experienced before. The sheer speed made conventional tactics nearly obsolete, and the ability to climb and dive at previously unimaginable rates gave them a tactical edge that was impossible to ignore. The development of these jets, however, was far from smooth. Germany faced enormous challenges in engineering, manufacturing, and logistics. Jet engines were temperamental, often failing after just a few hours of operation, and materials shortages made reliable production difficult. The program was also hindered by internal politics and constant interference from Hitler, who insisted on using jets as bombers rather than interceptors, limiting their tactical effectiveness. Despite these setbacks, the jets that did make it into combat stunned both pilots and observers, demonstrating the potential of aerial technology when pushed to the limits of imagination. The tactical promise of jet fighters was clear. They could outrun Allied aircraft, strike with precision, and retreat before retaliation was possible. In theory, a squadron of Me 262s could have dominated the skies over Europe, protecting German cities from bombing raids and turning the tide of air warfare. In practice, however, these jets arrived too late and in too few numbers to have a strategic impact. Allied air superiority had already been established, and Germany's production lines could not keep up with the losses. Pilots were often inexperienced, rushed into combat without proper training, and vulnerable during takeoff and landing, when jet engines were most unreliable. The potential of these machines was extraordinary, but human and material limitations prevented them from fulfilling it. Beyond the Me 262, Germany experimented with a variety of other superplanes and experimental aircraft. Some were designed for extreme speeds, others for long-range bombing or stealth-like approaches, and a few even explored vertical takeoff capabilities. Many of these projects never reached operational status, either because the war ended before they could be deployed or because the technology was too complex to mass-produce under wartime conditions. These experimental designs, however, demonstrate the extraordinary level of ambition driving German engineers. They were willing to explore concepts that seemed almost science fiction, and in doing so, they laid the groundwork for future advances in aviation. The jet program also illustrates a broader truth about wartime innovation. Technology alone cannot win a war. Even the most advanced aircraft cannot compensate for shortages of fuel, trained pilots, or effective strategy. The Me 262 and other jets showed what was possible, but they could not reverse the overwhelming material and numerical advantage held by the Allies. In a sense, they were a glimpse of the future arriving too late, a vision of technological superiority that came after the opportunity to influence the outcome had already passed. Yet the legacy of Germany's jet aircraft program is profound. After the war, engineers and scientists from these projects were integrated into both American and Soviet programs, accelerating the development of commercial and military jets around the world. The Me 262, in particular, influenced the design of early Cold War fighters and continues to be studied as an example of engineering innovation under extreme constraints. In this way, Germany's wartime ambition, though unsuccessful in its immediate goals, helped shape the next generation of aerial combat and civilian aviation. The story of these jet fighters highlights the tension between imagination and practicality. On one hand, the Me 262 and other advanced aircraft demonstrated what human ingenuity can achieve when pushed by necessity and competition. On the other, it shows that technological brilliance alone cannot overcome strategic disadvantages. Germany's superplanes were extraordinary machines, capable of feats that stunned contemporaries. Yet their impact was limited by timing, logistics, and circumstance. Ultimately, the jet aircraft program embodies both the promise and the peril of wartime innovation. It reveals the extraordinary lengths to which a nation will go when faced with desperation, and the ways in which creativity can produce machines far ahead of their time. At the same time, it is a cautionary tale, a reminder that even the most advanced technology cannot substitute for strategy, preparation, and context. Germany's jets were harbingers of the future. But in the present of World War II, they were a brilliant idea arriving too late to alter the course of history. Germany's ambition during World War II did not stop at rockets, jets, or super-heavy tanks. Deep within secret laboratories and engineering offices, a new class of futuristic weapons was being imagined. Machines that, in some cases, seemed ripped from science fiction rather than grounded in the practical realities of warfare. Engineers dreamed of submarines that could travel undetected beneath the waves for months, of armored vehicles that could crush fortifications with unprecedented speed, and even of aircraft that could take off vertically, bypassing the need for runways. Some projects explored nuclear fission as a weapon of unimaginable destructive power, while others toyed with ideas that would later inspire hovercraft, stealth technology, and guided missiles. These concepts reflected the audacious vision of a nation willing to gamble everything on technological breakthroughs that might, in theory, change the course of the war. Many of these weapons never saw the battlefield. Some were delayed by the enormous strain of wartime production, while others were destroyed before they could be completed due to Allied bombing raids. In many cases, the engineers working on them were racing against impossible deadlines, attempting to turn theoretical physics into functioning machines under conditions of scarcity, secrecy, and constant threat. The designs themselves were often brilliant, showcasing an extraordinary understanding of mechanics, aerodynamics, and materials science. Yet the practical realities of war, shortages of fuel, skilled labor, and critical materials, meant that these projects remained largely on the drawing board. One of the most striking aspects of these futuristic weapons was the level of creativity involved. Engineers were not limited by tradition or standard military doctrine. They could imagine submarines capable of surfacing only to recharge batteries, glide bombs that could home in on their targets, and planes designed for vertical launch from concealed bases. These ideas reflected a mindset in which conventional constraints were suspended, and the possibilities of what could be achieved through science and engineering seemed limitless. The results, while often impractical, demonstrated a level of ingenuity that was decades ahead of its time. Yet these projects also highlight a recurring tension in wartime innovation: the difference between vision and execution. For every conceptual breakthrough, there were logistical hurdles that could not be overcome. A brilliant submarine design was useless without fuel, trained crews, and a safe port from which to operate. A futuristic aircraft could not be mass-produced in factories under constant bombardment. Even when prototypes were completed, testing and refinement consumed time that Germany no longer had. The war was accelerating toward its conclusion, and many of these advanced ideas simply arrived too late to influence events. Despite their lack of battlefield deployment, these secret programs had an undeniable psychological and strategic value. They served as propaganda, projecting an image of Germany as a nation still capable of astonishing technological feats. They also inspired hope within military and civilian circles, suggesting that a single breakthrough could still turn the tide of a war that was increasingly going against them. In essence, these futuristic weapons were as much about perception as reality, about maintaining morale and the idea of invincibility, even as the practical circumstances made that illusion impossible to sustain. The legacy of these projects is significant. While they did not change the outcome of World War II, they influenced post-war technology in profound ways. Concepts explored by German engineers were later adopted, refined, and deployed by both the United States and the Soviet Union, shaping the development of guided missiles, stealth technology, nuclear submarines, and modern aviation. The ideas that were once theoretical or experimental became foundational to the next generation of military innovation, demonstrating that even failed projects can leave a lasting imprint on the world. What makes these futuristic weapons particularly fascinating is the blend of ambition, desperation, and ingenuity that drove their creation. They illustrate how a nation under extreme pressure will push the boundaries of science and engineering in ways that would be unimaginable under normal circumstances. They also reveal the limits of human ambition. No matter how brilliant the designs, no matter how advanced the technology, Success in war depends on timing, resources, and broader strategic conditions. For Germany, the gap between imagination and reality was too wide to bridge, leaving these advanced projects as tantalizing, what could have been, rather than decisive tools of victory. Examining these secret programs provides a rare glimpse into the mind of wartime innovation at its most daring. It shows what happens when necessity drives creativity to extremes and how visionary ideas can collide with the harsh constraints of reality. Germany's futuristic weapons were a testament to human ingenuity, a glimpse of technological potential far beyond the ordinary, and a reminder that even the most advanced machines are ultimately bound by the world in which they are created. In the end, these concepts remain both an inspiration and a cautionary tale. Remarkable in vision, but limited by circumstance, arriving too late to rewrite the fate of a nation at war.